Previously, we have learned relation and function. So this is the second subtopic, which is composite functions. Let's see the definition of the composite function. Given two functions, f and g, the composite function denoted by f and g is defined by f dot g and is defined as this one. F, small letter f and g, f, this one is actually not dot, it's kind of a small circle, g, and then we have function x, which is equal or can also be written in this form, f bracket g x, okay, which means that the terms, we have two functions, f and g. The function at the back is the one that you're going to substitute into the first function. For example, here we have f and g. G is the back term, or the term at the back. So you're going to substitute g function into the f. Let's see the first example. Given that function x, given that fx equal to 3x squared and gx equal to square root 1 plus x. So now you have to find a, g dot f, and also f dot g. So the first one, g dot f, mean you see over here, we have f as the last function. So this f function we're going to substitute into the g function. So you can write it down also in this form. So now you have function of x, which is 3x squared. So you're going to substitute this fx into the g. So what is your g? Your g is actually square root of 1 plus x. So you have x over here that we're going to substitute with the function of fx. So it's no longer x. You're going to substitute this x with 3x squared. So you got this. Square root of 1 plus 3x squared, because the x previously you just substitute it with the fx. And let's see the second example, which is f dot g. So for this term, you're going to substitute the g into the f. So let's see, this is your f, this is your g function. So you're going to substitute g into f. What is your f? Your f is 3x squared, which means that this x you're going to substitute with the g. Okay, let me write down a little bit. So you're going to substitute this x with this g. Okay, so you have 3x squared. This x going to substitute with the whole thing, square root 1 plus x. And then don't forget, bracket, you have square over here. So then you just expand it, then you get this answer. Okay, let's see example 2. If you have function fx equal to 2x minus 1 and gx equal to x cubed, then you're going to evaluate. Evaluate means you're going to find the value for that. Okay, for example here, a, g dot f when the x equal to 3, and this one b, f square when the x equal to 3, and this one when you have function of fx square when the x equal to 3. So let's see it one by one. We have these two functions. First one, g dot f when x equal to 3. So let's see, you have, which means that this f you're going to substitute into g. So your g is x cubed. So this term of x you're going to substitute with this whole thing. Okay, 2x minus 1 2x minus 1. But now you don't have, okay, I miss cube over here. There's missing cube over here. Kuasa 3. Okay, for now, this x is no longer x. You're going to substitute it with 3. Okay, you're not going to use any term of x. You're going to substitute with 3. So that's why you have this x cubed. Okay, so you're going to substitute with 2x minus 1, but the x you're going to substitute it with 3. Then it becomes 2 times 3 minus 1. So when you expand this, you get it is actually 5. So now you're going to find 5 cubic. Okay, 5 cubic, which is equal to 1 to 5. That is what does it mean by evaluate. You need a value for your answer. And the second one, f square 3. F square 3 mean we just focus on this f function, which means that you're going to substitute f into f. So you have like this. The function of f is actually 2x minus 1. So you're going to substitute this x equal to 3 over here. Okay, so you have 2 times 3 minus 1, which is equal to 5. Then this 5 you're going to substitute into f function, this f function. So again, the f function is actually 2x minus 1. So you're going to substitute this x with 5. Just now you get this 5 minus 1. So you get the n answer, meaning that you're going to double substitution. You need to perform double substitution where you have f square over here. You substitute 3 into f, then you get the answer, which is 5. Then you substitute this 5 into the f again. Okay, so let's see C, f3 and then square. So for this thing, it's quite different with this because the square is actually for the whole thing over here, for the whole thing in the bracket. But for this one, this square is only for the f, which means that when you perform this f square, this f you need to perform double substitution, 2 kali ganti masuk f ke dalam f tu. But this one is different. This is the square is for the whole function. So you just need to substitute f3. f3 meaning that you have fx to x minus 1, right? So the x ni, this one, you're going to substitute it with 3. So you got 2 times 3, 6 minus 1, you get 5. So you have 5 over here. Then don't forget to take square over here. 5 square, then you get 25. That's it. For example 4, given that two functions as well, fx equal to 2x and gx equal to 1 plus x. And you have 3 functions and you have hx equal to x square. So find as a function of x, first one, f dot g dot h, meaning that you're going to substitute h into g and then you're going to substitute those answers into f. So you start from the back. Let's see over here. So again, you have 3 functions. So you have f dot g, you're going to substitute it with f dot g should be, suppose it's going to be f dot g and then here is x, but right, it's supposed to be like this usually, or previously you have learned f dot g and then x, but this x you're going to substitute it with h because you have 3 functions over here. So it's become no longer x, it's become hx. So you refer back, what is your hx? Your hx is actually x square, so that's why you have x square over here. So let's perform again f dot g over here. So this is what we have done many times before, f dot g. So you're going to substitute g into f. G into f. So what is your f? Your f is 2x. So this x you're going to substitute with g, which is 1 plus x. So you have 1 plus x. But now this x is no longer x because previously we substitute the x with x square, right? So the terms 1 plus x become 1 plus x square because this one. Okay, so you just expand it to the function of f is 2x. So 2 times this whole thing. So you get this. Okay. And example 5, the function f, g, and h are defined by this whole thing. You have three functions. So now you have to show that f square x equal to x. So we have learned how to solve how to perform this one, f square, meaning that you're going to do double substitution, f again, and then you substitute again into f. Then find an expression of g square x and state for which two values of x it is undefined. And then solve the equation h cube x equal to x. So it's getting complicated here. You have f square and then at the end you're going to have h cube, h kuasa 3. So solution, you have fx equal to 2 minus x. So if you have f square, you can write it down into this. So f, you substitute with fx. This fx, you're going to substitute into f. Okay. So what is your fx? Your fx is 2 minus x. So this 2 minus x, again, you're going to substitute into the f. So you have 2. You write it down 2 minus, and then this x over here you got, I should erase this one. So this x over here, you're going to substitute with this whole thing, 2 minus x. So you just expand it and you get this x. Okay, you got what I mean, right? Two substitution, dua kali ganti masuk. First one, you ganti masuk fx into f, which is this one. It should be x, but you gonna term 2 minus x. And then this 2 minus x, you substitute again into this whole f. Therefore, you get f square x equal to x. You have shown that this is actually equal to x. Then for b, you're going to find g square x. Again, you can write it down in this form. G square x, if you have g square like this, you just write it down into this. G and then bracket g x. So this is your gx. So against this gx, you're going to substitute into the g. So what is your gx? This whole thing, 3 over x plus 1. Now you're going to substitute this into the g again. So what is your g? 3 over x. Now this x you're going to substitute with this whole thing again. 3 over x plus 1. And then you have plus 1, just write it down plus 1. So now you can solve for this, you get this one. So let's see what does it state over here. Gx is undefined for x equal to negative 1. Why is it? It is undefined when x equal to negative 1, because if you substitute x equal to negative 1 over here, this one become 0. Okay, so 0 divided by this thing, you get undefined. So it is not possible to evaluate g square when x equal to negative 1. And then second point is that g square x is also undefined for x equal to negative 4. Because when you substitute here the x value into here, you get negative 4 plus 4, you get 0. Okay, anything divided by 0, it is also undefined. So these two numbers, x equal to negative 1 and x equal to negative 4, makes your function undefined. Okay. Therefore, when x equal to negative 1 and x equal to negative 4, g square is undefined. Then for c, okay, so for c you have h cube x, but don't worry, for this one we can write it down in this form. You have h, again you use bracket, then you have h square x. Okay, h square x, we just factorize it, kita factorkan dia. Then you have h, just write it down again, h square x, where h square x is actually this one, you already performed it earlier. So hx, this is quite similar with f square x and gx, right? So you have hx, you're going to substitute into h. So you have your hx is 2x minus 1 from here. You're going to substitute again into this. So 2 times this x equal to 2x minus 1 again. Minus 1 again, then you get this. So now you have this thing, you can substitute into this. Okay. So you have h cubed x is actually 2 times this whole thing that you already found, and then you get the last answer will be at 8x minus 7. So when h cubed x equal to x, 8x minus 7 equal to x. So you just, this one is you just what do you say, rearrange. You just susun semula, you just rearrange this until you get the value of x. Okay, because the equation need you to solve the equation for this equal to x. So solve meaning that you need to find the value for x, which is your value for x equal to 1. Okay, example 6. The function f and g are defined by fx2 equal to 2x plus 1 for x is element of real numbers, and gx equal to this for x cannot be equal to 1. So now you need to find an expression for f gx and determine its domain and range. Okay, so this is a composite function f gx, which means that you're going to substitute g into f and then find an expression of g fx. Okay, this one is vice versa, terbalik pula. You need to substitute f into g and determine its domain and range. Okay, let's solve one by one. F for a, f gx means that you're going to substitute g into f. So what is your g? Your g is actually this thing. What is your f? This is gx. What is your f? Your f is 2x plus 1. So now this x, you're going to substitute with this whole thing. So it's become 2 times 1 over x minus 1 plus 1. So this one you can expand it till you get this answer. So from here, you can determine your domain. What is your domain? Domain is your x values or your input. Okay. For fgx, the domain will be x, all x, which is element of real number. Boleh jadi semua number of real numbers untuk x. But except x equal to 1. Why is it? You can pick any number for the domain, which means that x is numbers of real, h is an element of real numbers, okay? But not x equal to 1, because if you substitute x equal to 1 into here, you will get 0, which will get your function undefined. That's why we cannot choose x equal to 1. Okay, by expressing x in terms of y, that one is your domain. So to find your range or your y value, you express x in terms of y. The range is this one. Okay, it's quite similar. It's just that you change that x value into y. So the y also cannot be equal to 1. Otherwise, you get your function undefined. And for b, composite function of g fx, meaning that you're going to substitute f into your g. So what is your f? Your f is this one, 2x plus 1. 2x plus 1. I'm sorry, what is this thing? Ignore this thing, okay? This is actually 2x plus 1. Your fx. This is your fx. So you're going to substitute this fx into g. So your g is here 1 over x minus 1, which means your x over here going to substitute this whole thing. So you have x is actually 2x plus 1 minus 1. So you get this one. So again, the domain will be all the real numbers except x equal to 0. Because when x equal to 0, again you will have 1 over 0, which is your function, composite function, going to be undefined. And again, for the range or your y value, range is y value, domain is x values. So you just interchange it, tukarkan dia, you get similar answer but in term of y. And example 9. Okay, for example 9, we have function of g, this one, and composite function of f and g. So now you're going to find fx. It's the other way. Previously you have f and g, you need to find the composite function. But now you have g and you have the composite function of f and g, you need to find f, single f. So you just, for the solution, you have this one, f, the composite function fgx, which is equal to 10x minus 9. So we going to decompose it ataupun kita akan leraikan dia. So you have fgx. When you decompose it, you have like this, okay? Fgx is actually 2x plus 3 equal to 10x minus 9. So now we're going to let this whole thing into y. Okay, so to make it easier for you, and instead of writing down this whole function, okay, you're going to just write it down as y. We let y equal to 2x plus 3. So now from here, you're going to rearrange that, rearrange it so that you get only single x, okay? Single x in term of y. Bila kita dah susun, you get this one. X equal to y minus 3 divided by 2. So why do I need this? Is that, therefore, so I have like this. Therefore, fy, over here, you see fy, because this whole thing is changed into y. So you get fy equal to 10x minus 9. Your x over here, we're going to refer it to this, okay? This is actually this step. Dia ganti dah. Dia dah ganti masuk this whole thing with y. This x, you're going to substitute with this one. Okay? This x, you're going to substitute it with this. So you get y minus 3 over 2 minus 9. Again, you just solve for this, rearrange it. You get 5y minus 24. And again, don't forget by substituting y equal to x, then you get, jangan lupa tulis semula, tukar semula this one y into x, you get 5x minus 24. Okay, because you want to find fx, not fy. So this is the final answer. And the last example, example 10, if f, composite function of f and g equal to f 4x squared minus 2x plus 1 and gx equal to this. Now you need to find composite function of g and f, g dot f, okay? So dia terbalik pula. Hence, find the values of x that satisfy f dot gx equal to this. Okay, so let's see the first one. You need to find this one. So the first question is you need to find this one. Okay, so you have f gx, which is this. So again we're going to decompose it. Kita leraikan dia. So f gx. What is your gx? Your gx is 2x plus 1. And write again this whole thing. Again, you're going to substitute this whole thing with y. Let y equal to 2x plus 1. And again, from here, you're going to rearrange it until you get x term. Why do I want to get x term? Because I'm going to substitute this x letter into this, okay? So now you have fy. This is actually from here, okay? Fy, and then you have 4x. This x, I'm going to substitute it with this whole thing. So you have 4 times y minus 1 square minus 2x. You have y minus 1 over 2 plus 1. So again, you can expand it till you get this one. But don't forget, you want your answer to be in term of x, not in term of y. So don't forget to substitute y equal to x. Okay. So when you substitute y equal to x, you get this one. 2x plus, oh sorry, you have y squared minus 3y plus 3. When you substitute, you get x squared minus 3x plus 3. So this is actually your function of fx. So you already found your fx. Now you need to find this one. This is the answer, the equation, the first question. You need to find composite function of g fx, which means that f you're going to substitute into g. So you already found your f. This whole thing we're going to substitute into the g. So this is fx, right? What is your g? Your g is actually this. Now you're going to substitute it slowly. 2 times x. Your x is equal to this whole thing plus 1. Then again, you're going to expand it until you get this answer. Okay, and then for the second question need hence find the values of x that satisfy this equation. So values, which means that you're going to have more than one value of x. So let's say given that this equation, dia kata function of a composite function of this one sama juga dengan this one. These two composite function are equal. So you already have the one from the question, this one, and this one is you just find it earlier, this one. So you're going to rearrange this, susun semula. Susun semula 4x squared minus 2x squared until you get this, okay? Then up until here, you're going to factorize it. Okay, you're going to factorize it since it is square quadratic equation. So you get your x equal to -3 and x equal to 1. So this is the answer for the x values. X equal to -3 and x equal to, or x equal to 1. Okay, that's it for composite function. So don't forget to try it on your own and check whether you get the same answer as me. Okay, thank you.